Hey everyone, welcome to Tech Adventure. I hope you're enjoying your learning journey in software development, embedded systems, and skill enhancement. Today, we continue our Q&A series on C programming interview questions, a must-watch for anyone preparing to excel in real-world interviews. These questions are frequently asked and essential for mastering C programming concepts. If you missed the previous videos, I highly recommend checking them out first, as this session builds on what we discussed earlier. Whether you're a beginner or experienced professional, this video is designed to challenge you with new and insightful questions as we progress. Let's dive in and sharpen those interview skills together. If you enjoy my videos, please like, subscribe, and share with friends and anyone seeking this information. Without further delay, let's dive into today's Q&A session. 31. What is the size of a pointer in C? The size of a pointer depends on the system architecture, example, 32-bit or 64-bit. On a 32-bit system, pointers are 4 bytes. On a 64-bit system, pointers are 8 bytes. Pointers only store the memory address, so the type of data they point to doesn't change their size. 32. What is a dangling pointer? How can it be avoided? A dangling pointer is a pointer that points to a memory location that has already been freed or deallocated. The pointer itself still holds the address of that memory, but accessing or modifying the memory through the pointer leads to undefined behavior because the memory is no longer valid. Dangling pointers typically occur in the following scenarios. 1. When a pointer to a local variable is used outside its scope. See the example. Issue here is, the local var is destroyed when return local pointer function ends, so PTR now points to invalid memory. 2. When memory is freed but the pointer still points to it. Issue here, after free, PTR becomes a dangling pointer because the memory it points to has been released. 3. When a pointer is reassigned incorrectly. Issue here, PTR1 frees the memory, but PTR2 still holds the address, making it a dangling pointer. Here are the best practices to avoid dangling pointers in C. 1. Set the pointer to null after freeing memory. 2. Do not return pointers to local variables. 3. Avoid using freed memory. 4. Use of smart pointers, which we'll see in our next series of C++. 33. What is the difference between void pointer and null pointer? A void pointer is a generic pointer that can hold the address of any data type. It is used for generic programming where the type of data is not known in advance. To dereference a void pointer, it must be typecasted to the appropriate type. On the other hand, a null pointer is a pointer that does not point to any valid memory location. It is used to initialize pointers when they are not assigned a valid address, avoiding dangling pointers or unexpected behavior. By understanding these differences, you can use pointers more effectively and avoid runtime errors in C programming. 34. What is a wild pointer? A wild pointer is an uninitialized pointer that points to a random or unknown memory location. Since the pointer has not been explicitly assigned a valid address, accessing or dereferencing a wild pointer leads to undefined behavior. The term wild comes from the fact that the pointer's value, or memory address, is unpredictable and wild. It could point to any random location in memory. See the example. Here, PTR is declared but not initialized. It points to an arbitrary memory location. Writing $PTR equals 10 tries to write to that invalid location, causing undefined behavior or program crashes. We can avoid wild pointers using initialize pointers to null. Assign valid memory before use. Avoid dangling pointers. Static initialization. Here, also see the difference between wild pointer and null pointer. 35. What are double pointers and their uses in C? A double pointer is a pointer that stores the address of another pointer. In simpler terms, it is a pointer to a pointer. It allows us to manipulate the value of a pointer or work with data indirectly through multiple levels of indirection. Double pointers are widely used in various scenarios in C. 1. Dynamic memory allocation. 2. Passing pointers to functions, call by reference. 3. Multidimensional arrays. 4. Managing linked lists, trees, and graphs. 36. What is a function pointer? A function pointer is a pointer that points to the address of a function. Just as we can have pointers to variables, we can also have pointers to functions, allowing us to call functions indirectly via their addresses. See the syntax to declare a function pointer. See the example how function pointer used to add function. Function pointers are widely used in the following scenarios. 1. Callback functions. A callback function is a function passed as an argument to another function, allowing behavior to be customized dynamically. 2. Dynamic function selection. Function pointers allow you to select a function dynamically at runtime. 3. Implementing event-driven programming. Function pointers allow you to trigger specific functions or events based on certain conditions, like GUI or embedded system programming. 4. Array of function pointers. An array of function pointers allows calling different functions based on array indices. 5. Passing functions to library functions. Functions like sort in the C standard library use function pointers for comparison operations. 6. Implementing state machines. Function pointers are used to manage state transitions in state machines for systems like embedded programming. 37. Explain pass-by value versus pass-by reference. In programming, pass-by value and pass-by reference refer to how function arguments are passed to a function during a function call. 1. Pass-by value. In pass-by value, a copy of the argument is passed to the function. This means any changes made to the parameter inside the function do not affect the original value outside the function. The function parameter gets its own copy of the original data. Changes to this copy do not affect the original variable. See example of pass-by value. 2. Pass-by reference. In pass-by reference, instead of passing a copy of the argument, the address of the argument is passed to the function. This allows the function to directly modify the original variable. The function parameter is a pointer to the original data. Any changes made to the parameter reflect in the original variable. See example of pass-by reference. Here, key differences between pass-by value and pass-by reference. 38. What is the difference between star and bracket PTR plus I and PTR of I? Both are equivalent. PTR of I uses array subscript notation to access the ith element. Star and bracket PTR plus I uses pointer arithmetic to access the ith element. See the example and output. 39. What is the difference between star PTR plus plus and in bracket start PTR and plus plus? The difference between star PTR plus plus and in bracket start PTR and plus plus lies in operator precedence and how the pointer PTR and the dereferencing operator asterisk interact. Start PTR plus plus increments the pointer, not the value it points to. The asterisk operator dereferences the value at the pointer before it increments. And other hand brackets start PTR and plus plus. The parentheses change the precedence of operations. Star PTR dereferences the pointer to get the value it points to, and plus plus increments the value at the location pointed to by PTR. The pointer itself is not increment. See the example and its output. 40. Can you explain or write different pointers combinations? See the different examples. 1. In star PTR1. PTR1 can modify the value of x or point to y. 2. Constant star PTR2. PTR2 can point to another variable, PTR2 equals and y, but it cannot modify the value it points to. 3. In star const PTR3. PTR3 can modify the value of x star PTR3 equals 30, but it cannot be reassigned to another variable. 4. Constant star const PTR4. PTR4 can neither modify the value it points to nor change the pointer itself. 5. Int star star PPTR1. A double pointer that can modify the value of x through dereferencing star star PPTR1 equals 50. 6. Int star const star PPTR2. PPTR2 points to a constant pointer. You can reassign star PPTR2 to another variable, but cannot modify the value it points to. 7. Constant star star PPTR3. PPTR3 is a pointer to a constant integer. You cannot modify the value at the final level, star star PPTR3. 8. Int star star const PPTR4. PPTR4 is a constant pointer to a pointer. You can modify the value it points to, star star PPTR4 equals 80, but the double pointer itself cannot be reassigned. And that wraps up today's Q&A session part 4 on C programming. If you enjoyed the video, please like, comment, and don't forget to subscribe for more awesome content on programming. Also, feel free to share this video with anyone who might find it useful. In the next video, we'll explore more advanced topics Q&A like multithreading, structures, union, and enum. So don't miss it. Until next time.